We are excited to present our idea for the Walmart Spark-a-thon, an AI-powered waste management system for inventories. Our solution helps retail businesses like Walmart not only reduce waste but also cut costs, optimize operations, and most importantly, contribute to a greener planet. Now, moving forward with the problem statement, retail warehouses and supermarkets face serious inefficiencies in how they manage waste. The issues include inefficient internal waste collection routes, poor segregation with high contamination, no real time data on waste trends, and manual decision making that leads to massive losses. All of this increases operating cost and adds environmental damage, plus, it also leaves a huge carbon footprint. This matters with stats. Why does this problem need solving now? Let's look at some real world numbers. Globally, over 1.3 billion tons of waste are generated annually. $1.3 trillion is lost due to food waste alone. Up to 40% of food never reaches consumers, it gets wasted. And in retail, 32% of inventory becomes waste. Sorting errors can be as high as 80%, and 85% of systems don't have real time visibility. This basically has a triple impact. Firstly, financial losses, secondly, environmental damage, and thirdly, ethical concerns. While 828 million people go hungry, good food is thrown away. Now, moving forward with why is our approach useful? Let's look at why waste management in retail truly matters, especially in the food and grocery sector. Right here, you can see a breakdown of surplus food waste. A staggering 76% of all surplus food comes from just perishable items, and most of that waste can be avoided. The largest contributor is produce, like fruits and vegetables, making up 34% of the waste. Next is prepared food at 19%, followed closely by dairy and eggs at 16%. Even items like frozen goods and meat and seafood and beverages contribute. This chart makes it crystal clear that most of the waste isn't packaging or dry foods. It's food that could have been saved if only we had the right tools to monitor and act in real time. The- Now, moving forward with the methodology of our project, firstly, smart data collection. On the left side, we start with IoT sensors placed throughout the warehouse or supermarket. These monitor real time conditions like temperature, humidity, and expiry dates. We've used camera feeds and computer vision to identify items and waste types with an accuracy of up to 99.95%. Integrate with POS and inventory systems already in place. Secondly, advanced AI processing. Once the data is collected, it flows into our AI engine. Here, five major AI techniques work together. Firstly, neural networks help predict waste trends. Secondly, support vector machines classify product types and demand. Decision trees assist in setting auto pricing for soon to expire items. Genetic algorithms optimize internal waste collection routes, and linear regression helps analyze waste patterns and trends over time. Now, thirdly, real time actions. This is where a system becomes proactive. Dynamic pricing adjusts products' prices dynamically before they expire. Smart routing helps waste collection teams reduce transportation efforts by over 36%. And predictive alerts notify staff 7 days in advance before spoilage happens. Now, lastly, deploy and scale. We begin with a pilot program, maybe in one or two warehouses. From there, as results come in, we scale to more locations 5, 10, 50 plus lines. The system continuously learns and optimizes, leading us towards long term success. This end to end AI loop not only reduces waste but also increases operational efficiencies, cuts carbon footprints, and supports Walmart's sustainability goals at scale. Now, the tech stack.
This is the tech stack, basically a simple tech stack of our project. Let me walk you through the technical backbone of our AI-powered waste management system. We have designed the system to be both smart and scalable by integrating multiple technologies that work together. At the core, we use artificial intelligence and machine learning. These models help automatically classify incoming waste predict how much waste will be generated over time, and determine the most efficient way to schedule collections. This predictive intelligence helps reduce unnecessary pickups and ensures timely waste removal. Now, to enable real time decision making, we rely on IoT devices like smart cameras, sensors, Raspberry Pi, which are installed in bins and storage areas. These devices monitor fill levels, temperature, and even detect hazardous materials. They send continuous data that reflects the real time status of waste containers. Edge computing plays a key role here. How? Instead of sending every data point to the cloud, simple decisions like detecting a full bin or triggering a local alert are processed directly on site. This reduces latency and keeps the system responsive. All the collected data is then transmitted to our cloud backend, here through Fast API or Node.js, where it's securely stored and processed. The cloud infrastructure allows us to scale and perform more complex analytics such as long term forecasting and behavior modeling across multiple sites. To make this information usable, we have built interactive dashboards. These dashboards visualize metrics like collection efficiency, bin status, waste type ratios, and routing maps. Managers can view and analyze trends, make data driven decisions, and adjust strategies instantly. Staff can interact with the platform using a clean, responsive interface, whether on desktop or mobile. The front end is developed basically using React, offering a fast and intuitive user experience. Finally, we have made security a top priority. The system uses encryption, role based access, and login authentication to ensure that only authorized users can access sensitive data. And we have mentioned our security, what we have used, and what are the benefits. We have also mentioned all of these. Now we'll move to the next slide, that is our data research. Now let's look at why this tech stack matters in practice. What kind of results can actually be achieved when AI is applied in waste management? Let's start with waste collection logistics. In conventional systems, trucks often follow fixed routes, leading to inefficiencies like visiting half empty bins or missing overflowing ones. AI powered routing changes that. In real world tests, we have seen a 36.8 reduction in travel distance, which directly cuts down fuel use and emissions. On top of that, collection time has dropped by 28%, operational costs have gone down by around 13%. Next, automated sorting. With the help of machine learning, we have developed systems that can identify and sort different types of waste, plastic, metal, organic, etc., with rates ranging from 73% up to nearly 100%. That's a huge jump compared to manual sorting, which is slower, less consistent, and prone to contamination. This not only improves recycling quality but also reduces the cost of reprocessing contaminated batches. Now let's move to food waste in retail. Stores often struggle with products approaching expiration. AI-powered dynamic pricing solves this by automatically adjusting the price of near expiry items to encourage faster sales. In a pilot study conducted in Spain, this approach helped reduce waste by 32.7% and increase revenue by 6.2%. That's a win-win for both sustainability and profit. We also see a big impact in waste to energy systems. AI helps optimize combustion processes and monitor inputs more accurately. As a result, some facilities have seen 25% less energy consumption, 18% more material recovery, and 30% fewer emissions. This improves the overall environmental footprints of energy generation from waste. When we combine these results, basically the message is clear. AI isn't just a tool for automation; it's a powerful driver of efficiency, sustainability, and cost effectiveness in the waste management sector. It helps organizations cut waste volumes, lower expenses, reduce their carbon footprints, and increase recovery rates all in a smart data driven way. So, now we'll move to our next slide, that is basically our workflow of project. And we have mentioned a basic workflow on the right hand side that you can see. So, basically, this slide presents a high level overview of how our AI powered waste management system works. From the moment waste is generated to the point where decisions are made and results are measured. We start with the input, various types of waste collected from supermarkets and warehouses. This can include packaging, organic waste, expired goods, and more. Next, this waste enters a system where different AI techniques are applied. These techniques are trained to recognize waste categories and predict fill levels and identify optimal routes for collection. From there, we branch into key application areas. First, we use AI to optimize internal waste collection, making sure pickups are done efficiently. Then we have sorting, which separates waste with minimal human intervention. We also use real-time monitoring to track. We also use real-time monitoring to track waste generation trends and dynamic discounting to reduce the chances of food waste in retail by adjusting product prices as they near expiration. Once these actions are taken, we can measure the impact. We've seen results like a 36.8 percentage drop in transport distance, a 13% reduction in collection costs, and an overall improvement in sorting accuracy up to nearly 100%. Food wastes can also be reduced significantly by over 30% in pilot programs. Finally, we use the data gathered throughout the system to identify the patterns, improve predictions, and address any operational challenges. This workflow represents how the entire system works together, not just as isolated tools, but as an intelligent, connected process for better waste management. So, this was all about our project. And to conclude, I would like to say this is why combining a strong tech stack with proven AI models can create real measurable change in how we manage waste. It's not just about throwing technology at the problem, it's about using it thoughtfully at every stage to build a cleaner and more efficient future. Thank you very much.